Hi, I'm Melissa.
I'm Caitlin.
And I'm Maddie, and this is Michaela.
Great quality.
And we're going to talk about acids, bases, and salts.
Examples of acids and bases. An acid is a chemical substance that dissolves some metals, and a base reacts with acids to form salts, and the pH level is greater than 7. An example of an acid is hydrochloric acid and nitric acid. An example of a base is soap and lye. The appearance in water is one of the only properties that acids and bases have in common. Acids react with many metals and bases do not. Both acids and bases are examples of electrolytes. The reaction between an acid and a base is an acid-base neutralization reaction.
Acids and bases have different properties. Acids taste sour while bases taste bitter. Acids, when you touch them, they feel like water and they'll burn open skin. But bases will only burn you if they get in your eyes and they're smooth and slippery. They're both electrolytes. Acids react to metal while bases don't, and acids are an indicator while bases aren't. Indicators turn different substances, different colors, or different solutions, different colors, and bases don't do that.
A neutralization reaction is a reaction between an acid and a base. The ionic compound that forms in a neutralization reaction is called a salt. A reaction neutralizes both acid and the base in a neutralization reaction.
The Arrhenius definition of acids and bases. In acids, they dissociate in water to produce hydrogen ions. And examples of this are sulfuric acid, acetic acid, nitric acid, and hydrochloric acid. In bases, they dissociate in water to produce hydroxide ions. And examples of this are sodium hydroxide, potassium hydroxide, magnesium hydroxide, and calcium hydroxide. You know that acids and bases neutralize each other by the formula H plus OH negative equals H2O, which is water.
The Bronsted-Lowry theory. An acid is any substance that can donate H ions, and a base is any substance that can accept H ions. The Bronsted-Lowry theory defines acid and bases independently on how they behave in water. It also focuses mostly on H ions.
The Arrhenius theory is that acid dissociates in water with hydrogen ions, and bases dissociate in water with hydroxide ions. And the Arrhenius theory is specified to water. It doesn't really deal with anything else. Well, the Bronsted-Lowry theory is that acids or any substance donate H plus ions while bases accept H plus ions, and the Bronsted-Lowry theory is more general and it expands Arrhenius theory, and it's not specified, so it works with a lot of other things and it's better in that sense.
A conjugate acid is a substance formed when a base accepts a proton from an acid. A conjugate base is a substance formed when an acid loses a proton. A weak acid pairs with a strong base, and a strong acid pairs with a weak base.
What are the strong and weak acids, and how does that affect their conjugate acid-base pairs? In acids, strong acids transfer H plus ions to water to form H3O plus ions. In weak acids, it does not transfer H plus ions to water. With bases, in strong bases, they have the strongest affinity for H plus ions, and in weak bases, they react partially with water to form OH negative ions. There's a relationship between the strength of conjugate acid-base pairs because the stronger the acid, the weaker the conjugate base, and the stronger the base, the weaker the conjugate acid.
Now you should know more about
Acids and bases,
And salts.